Hello students, welcome back to our discussion of Chapter 15, Forecasting. So in the previous video we looked at two different forecasting methods, moving averages using a 3 or 5 month, 5-time period process, or exponential using the smoothing constant of 0.3 versus 0.5. What we're going to do in this video is look at trying to determine which one is more accurate. Because we know that forecast always deviate from the actual values. There's lots of different factors that go into determining what demand is going to be. We're using time series forecasting methods to predict future events, but there's always error. There's always a forecast error. We obviously want that forecast to be error to be as small as possible. If the forecast error is too large, then the technique being used is the wrong one, or perhaps some of the parameters need adjusting. So in this video, we're going to look at how to analyze and calculate that forecast error. So there's different techniques to do so. We're going to look at one of them called the mean absolute deviation. So deviation means a difference. It's going to be the difference between the forecast and the actual value. Absolute is going to make all those values positive, so it doesn't matter if we go forecast minus the actual demand or demand minus forecast. We're looking at the absolute deviation or absolute difference. And then the mean is just the average of all those absolute differences. There's different forecasting error methods, but we're just going to look at this one. The mean absolute deviation, difference between forecast and actual demand. It's most popular and one of the easiest ones to use. There's your formula. We're going to look at how to do this using Excel, so we don't need to basically understand that formula. It's, as it says there, it's just the sum of all the differences between demand and forecast, divide by n, so we get our average. So let's take a look at our Excel file that we have here. Let's go with moving averages. Now, one thing that we always want to do when we're looking at data is we always want to graph the data. So let's insert, highlight our data, and insert a scatter diagram. We can see here that it's going all over the place, that there is really no trend. And we can actually add a trend line, and it's kind of almost perfectly horizontal. So basically this tells us that the moving average is a good technique to use in this situation here. So what we're going to do here is to calculate the mean absolute deviation using both of those techniques. So let's just put that up there. We'll copy these ones there. And let's just make this all pretty. So this is the mean absolute deviation process for both moving average techniques that we use. So it's a difference. It's the absolute difference. So we're going to enter an ABS function. It's absolute difference between demand and forecast. And we can just copy and paste that down or drag that down. We're going to drag it down to the last real data we have. And then we're going to actually put that there. We're actually going to calculate the average of this data. Average, the mean absolute deviation for this is 27.1. And this is the value we want to compare. Now with the mean absolute deviation process for the 5-month moving average, we have fewer pieces of data to work with. So once again, equals ABS is the absolute difference between demand and the forecast. And we drag that down. Let's get rid of some of those decimals there. This one here doesn't look like there's any decimals. And we take the average. We can just copy this over. It has a smaller mean absolute deviation. So this would tell us that the 5-month moving average, the 5-month moving average is more accurate because it has a smaller mean absolute deviation. So the one with the smallest absolute deviation is technically more accurate. So let's move on to the exponential smoothing example we worked on. Once again, what we're going to do is we're going to draw a little graph of this. Let's highlight the month and the demand and get a nice scatter plot in there. We can see that there's a trend. We can highlight, right click, and look at that trend line. It's upward sloping. So there is some trend here, which is good for an exponential smoothing concept. And we have two situations here where we're taking 30% basically of the most recent and 70% of the more previous result. So let's do the same thing. Let's get rid of that space there. Let's develop or calculate the mean absolute deviation for both of these methods. With this one, it's going to be the absolute difference between forecast and demand. And we can just copy and paste that down. Same thing with this one. It's the absolute difference between forecast or demand and forecast. The way I'm entering those values. And we can drag it down. Let's get rid of some of the decimals, not too many. This one's not centered. Okay, and then we calculate the mean absolute deviation, which is the average of all of our values. 4.9, let's embolden that, versus 4.0. So this one basically says that the exponential smoothing method using alpha value, or that smoothing constant of 0.5, is more accurate. Oops. Sorry, I had a little technical difficulty, but I think we are all back. With the mean absolute deviation, we calculated that. The mean absolute deviation, 4.85. We calculated it to be 4.9 for the alpha constant of 0.3, but let's increase the decimal place. There we go. So, as I've said, the exponential smoothing method with the smoothing constant of 0.5 would be more accurate. Now, one thing we could do is we could have set up a system where we could then just really quickly change the smoothing constant and have that generate the forecast and have it generate the mean absolute deviation results as well. We could then determine perhaps if 0.4 is better than 0.3 or 0.1 is better than one of them. So that's something that you'd want to do, is to determine what the best smoothing constant is. Right now we know that 0.5 is better than 0.3. We could try other ones as well. So that is the extent of what we need to learn in Chapter 15 with forecasting.